Okay, so I'm going to show you guys a couple of test-taking strategies for the multiple choice section of the chemistry Regents. Okay. Again, the Regents exam is structured so that there are always a total of 50 multiple choice questions, 30 on part A, 20 on part B1. The second part of the Regents has also got some short answers. We'll go over those another day. Okay. When it comes to types of multiple choice questions, there's all kinds, but there are several different strategies that we can use to answer these questions, so I'm going to show you through a couple of these strategies. Sometimes they're testing two ideas at once. Sometimes some of the choices contain statements that are just absolutely false, according to the chemistry that we've learned. Sometimes you can put three of the choices in a category, and then you have an outlier. Sometimes, a lot of times, especially on part A, there's the question itself is a definition, and you just have to know, match up the word to it. Sometimes we get some sequence questions, and then also some compare questions. So let's take a look at a few of these questions. One of the things that I want you to see is that you can sort of start to think about the answer to the question before you even read the question. So if you look at these choices, this is a question that's testing two ideas at one time. What you want to do is make your first choice and then eliminate two answers, then make your second choice. So first decide, in this case, if homogeneous or heterogeneous is the correct adjective, and then decide if it's a compound or a mixture based on your decision. So let's take a look at the question. Right? So according to the chemistry that we've learned, the question itself says that we have a solution. We have a dilute aqueous potassium nitrate solution. And so you should recognize that the word solution, right, means that everything is dissolved, so that it's going to be homogeneous. Okay? So we can eliminate choices 3 and 4 based on that idea. All right? Then we can make our second decision. So if we make our second decision, right, we understand that the word aqueous also means that there's water involved. And we know that potassium nitrate has the chemical formula KNO3. So again, aqueous means mixed with water or dissolved in water. Since both water and potassium nitrate are present, then it's not a single compound, but a mixture of two different compounds. So we've got a mixture here. So again, we're using the strategy to narrow it down. First, decide which adjective was correct, and then we can make our second decision based on some more information. These types of questions show up pretty frequently, especially on part B1 of the Regents. Let's try another one. All right. So sometimes there are questions where some of the choices are just absolutely chemically wrong based on the chemistry that we've known. So again, we can eliminate answers that are what I like to call chemical lies. So without even reading this question, two of these choices should be absolutely false according to the chemistry that you've learned. So let's take a look. All right. Again, we know that positive ions are formed when electrons are lost, so they're always smaller. All right. Negative ions are formed when electrons are gained, so they're always larger. So choice number 2 we can eliminate because that violates this statement. Right. Same thing for number 3. That doesn't match the chemistry that we know. So the only two viable choices here are 1 and 4. So without even reading the question this time, we know that there's only two possible answers. All right. Let's take a look at the question, right? Well, now they're referring to the fact that an atom is going to lose electrons. And so the key word here is whenever we lose electrons, that means it's going to become positive. So choice 1 will be the best answer. Again, eliminating answers are chemical lies that allow us to narrow it down immediately, and then we can find our correct response. Okay. Here's another one where we should recognize that some of these choices are just chemically false. Right? So again, we can eliminate answers that are not true according to the chemistry that we know. So if you take a look here, we're talking about bonds either being formed or broken, and energy either being absorbed or released. Well, only one of these things is actually true. Again, only one of these things is actually true according to the chemistry that we know. So let's take a look. Right? Again, without even reading the question, we know that whenever bonds are formed, that's because the atoms are becoming more stable. And so that means energy is being released. Whenever bonds are broken, right, that makes the atoms less stable. So that means they have to absorb or they move to a higher energy state when that happens. Okay, so again, we're eliminating choices 1 and 4 because they violate this chemistry. So the only viable answers, again, will be choices 2 and 3. At this point, we can now read the question and decide what's happening. So we can take a look here. Again, they said given this balanced equation, we've got two atoms of iodine that are currently separate on the reactant side, and now this implies that they are now together, bonded together. So we recognize that this means that two atoms are combining to form a molecule. All right, so because a bond is being formed here, we understand that that makes the atoms more stable, so energy is released, so choice 2 is our answer. So again, looking for some statements that are just not true according to the chemistry that we know helps us to narrow down some answers, and then we can find our correct response. Okay. Sometimes you can put the choices into a category where 3 of the choices will fit a category and 1 of them doesn't. All right, so here, that's exactly what we're going to have. We're going to have an outlier. All right, clearly the one that's not like the others is going to be your answer. Okay, so let's take a look. Another test-taking tip that you should recognize is if I give you the name of something, you should be able to write the symbolic formula because it's easier to recognize what we're talking about. So you should know that ammonia is NH3, oxygen is O2, phosphorus is P, silicon is Si. Right? Now that we see the symbols, we can recognize that 3 of these choices are elements and only 1 of the compound. Okay? Again, writing the chemical symbols next to the names of these substances helps us to think about them a little bit more clearly. Okay, now that we know that 3 of them are elements and 1 of them are compound, well, that's got to be our answer. So we found the answer without even reading the question. All right, again, we can take a look at the question. All right, the question says, which substance can be decomposed by chemical means? Again, that's what makes a compound. All right, so that is the definition. We can recognize that we're looking for a compound here. Ammonia is the only compound listed. Oxygen, phosphorus, silicon, those are just elements. And that's what the biggest difference between those two. Okay, so again, we want to use some test-taking strategies in addition to the chemistry that we've learned this year. We should be able to be successful. Sometimes we just have to know the definition. So if you look at these choices, these are all just different vocabulary terms, all right? So the question itself is going to be the definition, and you just got to match them up, all right? Again, like I said earlier, this especially happens on part A. You want to think real simply. You want to know your definitions of key terms. So if we take a look here, the question says, which term is defined as a measure of the average kinetic energy of the particles of a sample? We should recognize that average kinetic energy is the key term here. All right, average kinetic energy, we should know, is the meaning of temperature. So again, we just need to know some simple definitions of some terms, and you want to keep that simple. All right, again, temperature is going to be our answer, so now we have our selection. So be aware of that, especially on part A. Sometimes in the question, we're just going to give you the definition, and you've got to match it up to the term. Okay, here we have a sequence question, all right? So again, we want to be able to figure out what's happening first and then narrow it down. So a lot of times you can see in a sequence question here, we're starting with 2 of the choices are starting with one thing, and 2 of the choices have something else, okay? So basically, you got to decide which one happened first, all right? So if we take a look here, this is about the sequence and the history of how we learned about the history of the atom and the structure of the atom. Again, our solid sphere model of the atom was first proposed by John Dalton. Okay, so we learned that the atom was like a hard sphere before we learned about this empty space concept. So that allows us to eliminate choices 3 and 4. Okay, now what we want to do is we want to keep narrowing it down based on the other parts of the sequence. And the second part of the answer here, right, we have atom is empty space or this orbital idea. Again, this is a little bit specific according to the chemistry that we've learned. All right, although electrons were discovered by Thomson before Rutherford proposed the empty space concept, orbitals are the most modern discovery and part of the most current wave mechanical model of the atom. All right, so again, the word orbital here you should recognize as being very current, and again, Rutherford discovered the nucleus and also this empty space concept, so choice 1 is the answer. So again, try to narrow it down, and these are some key strategies. Okay. Alrighty, what do I got here? So again, we were able to find the answer without even reading this question, right? Because this is the only one that's in the right order. If we take a look, right, that's all they're asking. They're just asking what is the sequence representing the correct order of historical developments. And again, this came first, then Rutherford, okay, and our most current model of the atom includes this concept of the orbital, all right? Sometimes we have some compare questions, right? Usually these only have 3 choices, so either the 2 things that you're comparing are equal to each other, or one is bigger or one is smaller, all right? So again, you want to think about this idea in terms of these kind of symbols. So here, let's take a look at the question and see what they're asking us to compare. Okay, they're asking us to compare a positive ion to the radius of the atom, right? So what we need to remember, like we said earlier, is that positive ions are always formed when electrons are lost. And so, as the atom becomes a positive ion, it always becomes smaller. Right? If we take a look, when lithium loses its 1 electron, it also loses that a second energy level, and so it is smaller as a positive ion. The same thing for sodium and any other positive ion. When sodium loses this last electron, it is now smaller as the ion. So again, when we're comparing the radius, the positive ion is always smaller than the atom, or the atom is always greater or larger than the positive ion. Okay? And so, here we can select our choice that because electrons are being lost, the radius of the atom is becoming smaller. All right? So you just want to think in these kind of terms here, and if you can make your comparison, then you can find your selection. Let's try another one, right? So again, here's another 3-choice comparison type of question, where what we want to do is we want to figure out if the two things that we're comparing are the same or if they're different, and we want to be able to figure out specifically how are they different. Okay? This is a tough question. It's a very specific chemical idea. So again, we want to couple the chemistry that we know with what the question is asking. Oops. Sorry about that. I don't know what I'm doing here. Okay, let me see if I can get this into the screen. There we go. Okay, so compared to the freezing point of a 1 molar potassium chloride solution at standard pressure, the freezing point of a 1 molar calcium chloride at standard pressure is, well, it's going to be lower. And let's think about the idea, right? Whenever solutes are added to solutions, the freezing point of the solution becomes lower. When comparing two different solutions, the solution with the greatest concentration of dissolved particles will have the lowest freezing point. So these two solutions, they have the same concentration, but if you think about it, this dissolves to produce only 2 particles. This will produce a total of 3 particles, right? So since calcium chloride contains more ions than potassium chloride, it will have the lower freezing point. So it's a very specific idea that we learned, but again, if we think about that idea, then we can easily make our comparison, right? So in other words, the freezing point of potassium chloride is higher than calcium chloride, or the same statement is this. This is the statement that we want to look at because the question is referring to the calcium chloride. Calcium chloride has a lower freezing point than potassium chloride. Okay, guys, I hope that you got some ideas about some strategies to answer some multiple choice questions. Again, you want to think about your comparisons, false statements, no definitions, narrowing it down in terms of sequence, look for outliers, okay, and also, finally, your 2 ideas, so narrow it down based on that. All right, hope you learned something. Take care.